Hello, I'm Tom Zetterstrom, a lifetime resident of Canaan, Connecticut, and an environmental activist since the first Earth Day. I have, over the decades, been involved with a variety of environmental issues, and as a fine arts photographer, have been observing the American landscape for the last half century, including our local region. We're going to talk about Japanese knotweed, introduced into New England in the 1890s and spread widely across the region since then. When it became apparent it was starting to march down my street in Canaan, I activated the North Canaan town crew and others to create a counteroffensive against it. Since then, that idea has expanded to the entire length of the wild and scenic Housatonic, and that's what we're going to talk about today. I will switch to my screen presentation now. Welcome to this talk. This presentation was originally given to the annual meeting of the Sharon Land Trust in October of 2020. Defeating knotweed on the wild and scenic Housatonic River was initially launched with the cooperation of the Housatonic River Commission, and the Housatonic on board with their support services. And as we progressed, we added more partners. Japanese knotweed is almost unique among invasive plants in that it has particular methods of transmitting to new infestations, most of which are assisted by human beings. I mentioned introduced to North America 125 years ago, it spread quickly to form dense thickets that exclude native vegetation and greatly alter natural ecosystems. It poses a significant threat to riparian areas where it can survive severe floods and is able to rapidly colonize scoured shores and islands. Once established, populations are extremely persistent. So it's an invasive that is a particularly challenging one. And because of the pristine nature of the wild and scenic Housatonic, we didn't want it to become a landscape of an Asian character. We wanted to keep it native and American. Knotweed travels widely and rapidly and easily through two types of corridors: riparian corridors following rivers and road corridors. First, we're going to look at riparian corridors, and here is an image from the Deerfield River in northwest Massachusetts. It forms dense patches, a monoculture, and here you can see that's about a mile long, excluding all other vegetation. Doug Talamay tells us that in those invaded areas, the biomass of insects is reduced 96% when compared to native riparian belts or hedgerows, for example. That impact on the riparian ecosystem has profound effects on the entire riparian food web, including for birds, fish, bats, lizards, insects, spiders, invertebrates. Um, and the ramifications would extend, therefore, beyond that to the larger food web. Number one, Eurasian milfoil is the most aggressive of the aquatic invasives. Number two, Japanese knotweed is the most aggressive of the terrestrial invasives. It is the weed that took over the world, according to the Financial Times. And you can see its distribution from introduced into Boston and affecting the Northeast and introduced on the West Coast and, hey, overwhelming much of Washington and Oregon. It progresses further and further across the states, even um, approaching the state capitol grounds in Hartford. In Northwest Connecticut, we are graced with the benefit of much preserved land that is protected from development, but however, not protected from invasive plants and certainly not from knotweed. The original landscape here looking into Connecticut from Bartholomew's Cobble, agrarian and forested, looks like this. And our objective is to preserve this riparian landscape, which includes agriculture. So it's not, hey, native in the total sense, but where forest areas and floodplains exist, we don't want them to become riparian areas of knotweed. So in 2017, 20 paddlers surveyed the 42-mile stretch of the Housatonic from the Mass border to New Milford. Documented riparian knotweed along the way with GPS settings on cell phones, and through the generosity of the Housatonic Valley Association, produced a map of that entire section showing the distribution of knotweed patches. Hey, to our relief, and based on our assessment, it was still within the manageable level. When we look closely at that northern section, Kane and Salisbury Falls Village, we see the density often appears along roadsides and to some degree along on the riverbanks. As we move south, where Sharon and Cornwall share either side of the river, we see the density is modest, though there are pockets where it accumulates, such as at the Covered Bridge and at the Cornwall Bridge. Okay, it was, shall we say, a dubious distinction that the largest knotweed patch on the entire 42 miles was in the town of Sharon, just north of the Cornwall Covered Bridge, West Cornwall Covered Bridge. Here you can see it's in two portions, the riparian belt right hugging the river and an upslope portion behind the former West Cornwall garage. Per there introduced in contaminated fill 20 years ago. And just above the covered bridge, Connecticut's most photographed piece of architecture, we wanted to prevent knotweed from redefining the landscape of that portion of the river, so it wouldn't look like the covered bridge just 25 miles north in Sheffield, which is flanked by knotweed. All the way to the north, flipping to both sides of the river, a monoculture that has redefined the term edge. Ongoing under the US Department of Agriculture is a biological control hope that may or may not materialize. Depend on it yet. It is in the early stages of the release of a Japanese insect called um, Alphidara itadori, and that is a psyllid sapping insect that will reduce the vigor of the plants. And if these insects survive, there may be a way of bringing the aggressive nature of the knotweed, lowering it into the level where it doesn't displace all natives. And so natives will have a chance to compete with it. Alphalera itadori. It's going to be 5 or 10 years before we know if that is promising at all. Glyphosate is killing us all appeared in the Lakeville Journal about 4 years ago as a commentary by Sharon, writer and respected environmentalist Tony Peel and birder. But a week later, Tony did concede. To be perfectly clear, we are not talking about the careful, responsible, safe, and effective application of glyphosate by Tom Zetterstrom and others to fight invasive plants threatening our native plant species. So we are making a distinction between the routine, annual, perpetual use of glyphosate in industrial agriculture, widespread, and the careful, isolated, and targeted use of glyphosate in the control of invasives in this talk. Robert Kennedy on Earth Day 4 years ago said there are two issues. One is glyphosate alone is less toxic than glyphosate in the formulation of Roundup. So that's another distinction we're making. We're not using Roundup. Um, Roundup contains adjuvants that are and or surfactants known as toluamines that make glyphosate far more toxic, perhaps 10,000 times more toxic. So we make that distinction. What indeed we have been using is a wetlands approved formulation of glyphosate called Rodeo with a wetlands approved surfactant. We follow the weed control methods of the Nature Conservancy Handbook, and we recognize that the half-life of glyphosate averages 2 months. It isn't absorbed or taken up by the roots of other non-target plants, and it is very low toxicity. When confronted with the site on the west bank of Housatonic at the covered bridge, one is slightly daunted by its size, as big as a barn, really. Here, two river commissioners, Christian Allen from Canaan and Robert Gambino from New Milford, are contemplating the counteroffensive. And because it was as well established and tall, a 12-foot orchard ladder was required to apply the herbicide, foliar application. That was done on September 21st of 2017 on a still, sunny, dry day where no droplet of herbicide drifted. And the only target that was hit was the intended target of the canopy of glyphosate. So a year later, we see the effect of that, and we had very high kill, um, which is the intention. The patch in the middle that was not even approachable with the reach of the hose was treated the following year. So we're up to 2018. And here Bob Gambino is making that application again, only to knotweed. Across the river, where we saw that little patch by the covered bridge, um, there was an attempt made to control that knotweed by mechanical means, meaning tarping or um, containment with fabric. However, the following spring, the knotweed said, I'll have nothing to do with this, and just pushed that out of its way. That's not a, that can be a suitable method of control. However, as Bruce Bennett says, it takes 40-pound boulders to hold that thing down and have any effect. And it takes 5 to 10 years of coverage to fully kill the root system, which is the absolute necessary goal. An alternative method to foliar application is stem injection, which requires 2.5 milliliters per stem and is very effective on small clusters. However, the size of the treatment area that we were taking on would be astronomical in the number of stems and basically an impossible physical feat. However, here a small cluster can be effectively dealt with. So what we ended up with after that second area level of treatment is the standing stems still the following spring. And then, but already in the lower area, we were getting regeneration of Queen Anne's lace and other natives. Here we see a picture in the third year where River Commissioner John Saunders from Sharon and Sharon Tingley, Sharon resident, are sowing conservation mix on the area the following spring after the collapse under the snow, leaving the knotweed stalks in place as a form of mulch. and on a dry day, spreading the seeds and they drift down in between the stalks. And lo and behold, later that year, it looks like this. So imagine this by comparison to this. That was our goal and that was our achievement. In the riparian area, you'll see it in the lower right, just again above the bridge, a few hundred yards. We did the treatment in that same first spring, September, and the following spring, and this will be 2018, uh, we see skunk cabbage already emerging because the skunk cabbage was covered by the canopy of knotweed and therefore unaffected by the glyphosate, which has to have contact with the foliage of the plant. Um, Notable birder and kestrel hawk restoration activist Art Jengert of Cornwall sowed conservation mix there on Earth Day of that year. By June, we were seeing rejuvenation and reintroduction of grasses. We see a couple of sprigs of knotweed poking up there in the center left section. And by late August, we've really restored the area. Imagine a year ago, this was a impenetrable wall of knotweed. A year after that, we engaged with Mike Jastrzemski, who is the wetlands restoration coordinator for the Housatonic Valley Association, and with Deb Bennett of the Cornwall Conservation Commission, examined the site, came up with a planting plan, and October of 2020, planted 50 native plants where once knotweed grew. Here on the right on the riparian edge, that was an entirely a monoculture of knotweed. As we moved forward, oops, I jumped again. We celebrated that event as an educational event attended by William Tingley, the chairman of the Housatonic River Commission, and representatives of land trusts and other volunteers, including from the Northwest Connecticut Conservation District. At that site, we were at the very far right end of this axis, near the biological potential of the invasive, where control costs are high. And we would have preferred to have addressed that, 10 or 15 years ago around early recognition, or 20 years ago at introduction, or perhaps had been smart enough, but back then we were quite unaware that the first occurrence would have been an easy treatment. Switching now from riparian environments to roadside, we notice early detection. Here, a sprig that could be taken out in 1 minute rather than a 3-year effort. Here, 2 minutes. Here you can see the roadside manager of District 4, Connecticut DOT, probably spent 2.5, 3 minutes treating that knotweed. This is something we have been encouraging in our cooperation with the Connecticut DOT. Here, it might be a 10-minute project. Likewise here. Now, what's become evident to us as we observe where does knotweed appear, unfortunately, it's nearly always on a roadside project, which means there has been disturbance there, introduction of fills, and contaminated fills. At the North Canaan, Connecticut DOT garage, we see evidence of this in knotweed growing right in their soil storage areas. At the Cornwall gravel pit, same circumstance. At the North Canaan sand pit, same circumstance. At the Falls Village gravel pit, knotweed occupying much of the fill. This little site where there was a excavation for a drainage channel, knotweed did not fall out of the sky. It was dumped there from a pickup truck. brought over from the Cornwall gravel pit. So that is the human vector of the transmission to new sites. In North Canaan, we mapped all knotweed on town roads and riparian areas and have treated all knotweed on town roads and on town land, reducing our knotweed populations by 80%. In Cornwall last year, mapping was completed, and when one observes the distribution of knotweed in that town, one might draw the conclusion that somehow it has something to do with the highway network and where it came from, in that both the Connecticut DOT Cornwall garage and the town of Cornwall gravel pit both have contaminated fill. So we are inflicting knotweed on our own landscape. Therefore, we got a grant from the Northwest Connecticut Community Foundation for the town cruise of the 7 towns of our region, hosted at the Falls Village Firehouse. Robert Gambino, the grandfather of invasive management in Northwest Connecticut, was the primary presenter. And we basically were educating towns on how to prevent self-infliction of knotweed, and demonstrating how to apply the herbicide on roadside areas, treating the foliage to glisten, not to drip, avoiding treatment during the blossom period so we don't conflict with foraging honeybees. Um, on Connecticut DOT Route 44, we see knotweed presents a line of sight issue and not a particularly suitable area for mowing. So treatment in year 1, follow-up spot treatment in year 2. By year 3, reverts to native plant seeds that were not sown actually, but that just spontaneously emerged. We've done similar treatments in Canaan where we eliminate the knotweed and allow natives to return. Sometimes we use a conservation mix if it's a particularly bare or steep area. Spraying onto the tops of the plants is important. In other words, we see the target and we know what we're hitting. It can involve simply a 4-gallon backpack sprayer or a truck tank sprayer. Mowing knotweed, on the other hand, has unintended consequences in a riparian area where a brush hog just spews flailed fragments of knotweed into the brook. As we can see, there's a piece. It floated downstream. You can see knotweed growing on the bank. That's how that knotweed got there. Again, human transmission, and that is considered not a good practice. In Massachusetts, where herbicides are not permitted on roadside vegetation management, it is greatly to their disadvantage as they try to flail mow this knotweed and spew fragments into the Housatonic River, the very river we're trying to protect in Connecticut. You can see they are even pressing down that mower into the dirt, wondering, how can I kill this plant? And they'll never kill it that way. The roots are 60% of the biomass of the plant. The way you kill the roots is either by covering it and suffocating it with black plastic for 10 years or using glyphosate that in the end of the growing season, when the chemistry descends into the root system and kills the roots. Here, mowing could be an option. There's no right area and it's accessible, but it would need to be done repeatedly and frequently, annually, year to year to year. Best management practices are well described in Penn State University's brochure or the New Hampshire Department of Agriculture's manual on knotweed management. It's actually a known science. It's effective, and in various towns and various states, it's well controlled. To review the points of the lecture, knotweed evaluation is the starting point, and that includes riparian and roadside surveys using iPhone GPS turned on Fortunately, we had the HVA mapping department at our service. Prevention follows evaluation. Prevention includes early detection and rapid response where possible, always the most efficient, least cost of approach. One major goal is to don't wound yourself. Keep gravel and fill storage areas 100% knotweed free. Otherwise, you will be distributing that material contaminated. Avoid flailing Japanese knotweed propagules. Those are the fragments of the plants into water or wetlands, such as from behind a brush hog. Flag roadside patches. And what that does is identifies for the town that's an area that should be treated with herbicide, not by mowing. But limit your mowing to preserve line of sight issues. And those are where you have signs, curves in the road, or driveways coming out where you may need to bring the mower in for that safety purpose. But always clean the knotweed from the mower deck before you move down the road so you don't deposit new propagules and establish new sites. With regard to treatment, timing is important, and that occurs in the late growing season, late July, August, and really late September, and even into October until there's a killing frost. We typically chose to treat in the last week of September. Um, we avoid the blossom period, which is around mid-August to early September. That's when foraging insects are out there. The first treatment provides 70 to 90% mortality. The second treatment is really a fraction of that, maybe 10%, the last 90 to 99%. Then in the third year, there's a few sprigs, and we're in that last 1% spot treating and are effectively shutting off all above ground support to the 60% of the plant, which is the biomass underground. Killing the roots is essential. Restoration follows or occurs overlapping with control. We sow ground cover and naturalize the area and allow native seeds that are in the soil there to emerge because we've made space for them. The riparian replanting of native shrubs occurred in our case in the third year. And by then we are well along the way toward 100% control. However, we will monitor that site for an additional 2 years. So we're looking at the total project scope of about 5 years using that method. I think that is smaller, I should add, smaller patches can be controlled probably in year one. They might even be dug out if you can just find the contaminated rhizome that got deposited. So you want to actually, I guess the answer is check your source of fill before you dump it on your yard. So the contrasts are defined by this. This is year 2, and this is year 3 behind the West Cornwall garage. Here we are the spring after the first treatment, about 7 months later, and 8 months later, and that's the contrast. The partners were the paddlers, 20 of them from the mostly Housatonic River Commission, Housatonic Valley Association, which supported with mapping, department services, and restoration. Northwest Council of Governments, we've worked with and done several presentations. Northwest Connecticut Community Foundation, Sharon Wetlands Commission, which provided permission for the project, the standard permitting process, public works departments of various towns, local land trusts, and professional herbicide applicators and invasive managers, Robert Gambino and Christian Allen, who are also both river commissioners. Thank you. This is a human caused environmental problem, and there are human solutions to it. We don't want our landscape to be defined by unintended consequences or simple avoidance of the issue. It can be corrected. Our wild and scenic Housatonic, for all of its virtues, may also in the future be defined as a section of the river not controlled by an invasive plant called Japanese knotweed. And that will distinguish it from other wild and scenic rivers, such as the Farmington or the Delaware River, which are severely impacted by that plant. So we know that it could get worse. We're at a stage in this process where we can reverse the negligence and preserve the integrity of the river. Thank you very much. Um, yes, I want to add, we're not doing this blindly. We're relying on some of the best people in the field, including Doug Talamay, one of our science advisors, Jeff Ward of the Connecticut Ag Experimental Station, along with Kim Stoner and Richard Coles and Jatinder Avalak, all of the Connecticut Ag Experimental Station, Dr. Todd Mervosh, David Gumbart of the Nature Conservancy, and Glenn Dreyer of Connecticut College, now retired. So we're quite confident that we are being using glyphosate in a highly targeted, discrete, limited, well-timed manner to defeat the invasive, allow restoration, and then move on to the next project. Good afternoon.